Okay, back with part two. And my apologies for the the shoddy camera work, and I also do have lighting challenges here. I don't have a proper workspace, and I don't have a properly mounted camera, so I kind of have to hold it with one hand and try to film and explain stuff at the same time. And that's why I can't uh, fill a lot of this stuff out while I'm actually filming at the same time. Is why I do this in steps here. But nonetheless, I'm gonna try to complete this one here. And so there's stuff here that I'm not going to bother showing this time. How to do this with a drawing compass. I think most people can get this information elsewhere, and they're probably already um, able to do so. It's just really basic stuff. To set up your basic your two axes, your vertical and your horizontal, with a straight edge ruler and a drawing compass. Is what I think I failed to mention that in the last video. You need a straight edge ruler and a drawing compass, essentially, are the only kind of two tools that you need. And so once you set up your vertical and your horizontal, you basically make a square. That's pretty straightforward. Any size, just as long as whatever you're doing will fit on your page. And your a triangle. Make a square and make an equilateral triangle, the one that fits inside the square. And the next step is this portion up here, and you stack that part on top of the existing square. And this portion comes from this section here. Of your square. And so you simply just take your diagonal measurement there, and that gives you that measurement there, and you mark it going one way and you mark it going the other way, and that gives you that point there. So that's how you get that step. And then the next one is you need to stack a quarter of that square diagonally on top of that one. So it's one of these. You need a quarter from the initial square, and you simply stack that diagonally. And you already have that measurement there, and you simply just take that and you mark it like this. And that gives you the top of there. And then the width, you could just get you can get that reference from one of those off that square, and you just mark it. Just like that. On both sides. And that's easy enough. And you just fill that in. So that's essentially that's the whole part of this. I've reverse engineered this to get to where I am, and after the fact, it's quite easy. So it's just a matter of stacking that portion on top of there, and then one of those on top of there, and that gives you the base of your Septagon, and that is going to be the very tip of your Septagon. And the next portion is why you need the triangle. You need to get the height of the triangle, that measurement, and you go to one of the corners of the square and you mark it. And you do that on both sides from the other corner, the other top corner, and mark it. And then you open your compass back up to the width of one of the sides of the square, and you go to the top point there, mark it, go to the top there, mark it on the other side, and that gives you those two reference points, which are the two sides, the top two sides of your septagon. And then from there, to get the other two, you just go to that reference point, make a mark there, go down to the corner of the square, mark it there, and you get those two sides. And you just do the same on the other side. Mark it there, and you get those two reference points, and then you can fill those in. You connect them all, and that's how you get your Septagon. And similar to the last video series, it was like a 5 plus a 3 fit inside an octagon. Only this is a bit different, but interestingly enough, the things that you need to find a 7-sided polygon, a septagon, is you need a 3 and a 4. Although it's in a different configuration here, which it took me a while to find this. I was playing around with it, and finally I figured out a way to make this work, so that you're just using a straight edge, a drawing compass, and starting with some, basic polygons. Just a square and a triangle is all that you need. And so, to jump ahead, that's what I had shown on my last video. You can see the finished product, and to check and see if your work is accurate, and you want to get a circle that goes through all of the outside points, you simply take that measurement there, okay, from one of the corners to the vertical axis, and you could take it from there, you could take it from there or there or there. It's this measurement, right? And what you do is you can go to any point on there, and you mark that mark in the middle, mark another one in the middle, and then when you draw a line from that mark to the opposite point, you draw a line from that point to the opposite point. Where those two lines intersect, that'll give you the middle. And then you can just use your compass, place it there, and go to one of those points on the outside and make your circle around. And then you can make sure that it's going through each one of those outside points to confirm that your work is pretty accurate. So that was it. That's it's after the fact. I mean, it took me a while to kind of figure this one out. It's a tough one because the Septagon, is the hardest one to find. Just using a compass and a straight edge, without using the 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 measurements on your ruler and or a protractor, um, and trying to eye out, the decimal places that you need to get a 7, like a 51.42 and of the 102.85 and all that kind of stuff. It's that's kind of tricky. Um, but this, however, it is a bit of work, but at the same time, it's very simple. Um, and it made me realize something else after too. You often see this symbol in some of the old Renaissance type of illustrations, and usually those illustrations have to do with other kinds of subject matters, but they have these kind of like geometrical symbols where there's a square, and inside the square is a triangle, and sometimes there's a circle around the triangle in the square, or there's a circle around the square. If you're familiar with that symbol, it made me realize that that symbol that was used, often enough in like the Renaissance, for example, it's a foundational symbol for geometry. Um, and I mean, you think about it, like how did these guys do all that stuff back then? Like, a few hundred years ago, they didn't have any of this technology that we have today, and they literally, all they would have had is a straight edge and a compass, and just to do something as as just drawing um, a seven-sided polygon, for example, a septagon. Like, how would they have done that? And that made me realize, after finding all of this stuff, was like, okay, that's what that symbol was. It's a symbol for geometry, and at the same time, it's a foundational uh, um, um, geometrical symbol, because foundationally, that's what you need to do most of your geometry. In fact, most all of your geometry. Um, you need a triangle, square, and a circle, and that's what that symbol was about. And so, um, yeah, that's it for this one. Um, like I was saying, the finding the 7, the old-fashioned way, is the hardest one of them all. To find a basic triangle is very easy. To get a square is easy. A pentagon is not, that difficult. There's many ways of doing that, and if you can get a triangle, you can get just as easily get a hexagon. That's pretty easy. An octagon is easy-ish. It's a bit more work, but then again, it's not that difficult. But the 7 is a challenge, and so I just thought this was really cool, because I found a simple way, just using a drawing compass and a ruler, to find a septagon, a seven-sided polygon. And yeah, I guess I'm just gonna let this go on for a few more seconds before I stop this video. And that'll be it for this one. And Happy New Year.